Hi everyone, I'm Tim Kington and this is Coding is for the Birds. Daisy and I are working our way through the advent of code problems from 2021 and this is day 12. Alright, so we're trying to find paths through a cave system. So this is basically a graph, right? We have edges here. We could draw the graph. We want to find all the paths that start at start, end at end, and don't visit small caves more than once. Okay, large caves can be visited more than once, so uppercase ones. All right, that seems okay. So can we just do a normal depth first search, but modify our cycle checking for large caves so that we can go in large caves twice? We could get into an infinite loop if there's a large cave next to a large cave, right? Because we could just go back and forth between them forever. There aren't any large caves connected to each other here. I don't think there were in my input either. So I think we're okay. My input doesn't look like it has two large caves in a row. Okay, so let's try it with a depth first search. So we're going to say for lines, and we're going to want a graph, so I'm going to make my graph be a map. Set of string. And then for each line, we'll split it. Split on a space or a dash, and then we're going to say add edge, I guess. Yeah, sure. Add edge G, vertices sub 0, vertices sub 1. And this will take a graph. And then V1 and V2. And we'll say set of string v's equals g.get v1. If vs is null, we have to create it. Vs equals new set string, and then g.put v1 vs and vs.add v2. So we're going to do this twice. And now we have our graph. So now what we want to do is count how many ways there are to reach the end, right? So we're going to say DFS, the current vertex is start. I think that's what it was called. And we're going to have a list. We're going to have a list of the vertices on the current path. And that's it. I think that's it. I guess we'll do that inside the method. This is fine. And then we'll write DFS. So static in DFS, this takes v and list of string, which is our current path. I guess this could be, can this be a set? Maybe this should be a set, it'll be a little faster. It probably doesn't matter much, but I think we can make this a set. Oh. No, I don't. Let's leave it as a list. Okay. So we're going to say path.add Now we're going to say for string dest in g.get v, and that means we need to pass g in here or make it global or something. Let's just make it global. We don't need g here anymore. Okay, and we're going to say if the path is uppercase or unused, right? So if character is uppercase, dest.char at 0. So if it's uppercase, we can always use it. Or if not path.contains dest, then we're going to use it. So we'll say count. So here count 0. We're going to say count plus equals dfs of dest path. Okay, that's all good. Now if dest is end, we need to handle that. So I guess we can do that here. Yeah, we'll say if v equals end, return 1. Is this going to work? Kind of feels like it's going to work. It's either going to work or it's going to run forever, probably. Let's see what happens. Nope. That is not the case. Path contains. Oh, okay. It's we're not cleaning up the path. So where I add v here, I have to remove it before I return. How about now? 3485. That seems like a possible answer. Okay. We might have time to visit a single small cave twice. Specifically, big caves can be visited any number of times. Single small cave can be visited at most twice. Remaining small caves can be visited at most once. Boo. Wow, okay. A single small cave can be visited at most twice. All right, I think we can just change the logic a little bit. So here we'll pass in false. We'll have a parameter here for has visited twice. We'll say if it's uppercase or we have not visited twice, not has visited twice, or that. So this we also need to check. We haven't visited twice. I'll just create an expression here, I guess. Can visit twice is we have not done it yet, and dest is not equal to start, and dest is not equal to end. So can visit twice, okay? Now if if path contains dest, then we're going to set the flag. Visiting twice is true. I guess we should just say this is equal to path. Whoops. And then set has visited twice to true. And then if visiting twice, we'll set it back to false. Is this going to work? We haven't visited something twice. So if it's uppercase, or we can visit twice, or we haven't visited this before, then we can do it. Visiting twice is, okay, it's lowercase and that, right? Now we need an if here. This is kind of uglier than I expected. Visiting twice is only true if character is lowercase. Dest.char at 0. And path contains dest. And since we're doing that more than once, I guess we should put that here. Already saw. Okay, so if it's uppercase, or we can visit twice, or we haven't seen it. Visiting twice, if it's lowercase and we already saw it, we set this true, we call that, we clear it. Okay. Yeah, this is parentheses in the wrong place here. All right, so 85062. Larger, but not ridiculously large. All right. Well, this started out as a pretty straightforward graph problem that looked like just a depth first search, but then they put a couple of wrinkles in there that made this a really interesting problem. So on the first step, being able to visit large caves more than once meant that we had to track carefully the caves that we had already visited. And then on step 2, being able to visit one small cave twice made our logic a little bit nastier. It was right on the edge of where I started to feel bad about it. You know, we had enough Boolean flags and special cases in there that I was thinking maybe we should take a different approach, but it sort of was hitting that limit just as we solved it. Thanks for watching. Don't forget to like and subscribe.